Hello students, welcome back. The next topic is complex numbers, and this corresponds to section 1.3 of our textbook. What is a complex number? First, we begin with something called an imaginary number. Let's consider a certain number, an imaginary number I, such that I squared is equal to -1. Of course, that's not possible for any real number. That's why it is called imaginary. And then, let's take a couple of real numbers, x and y, and pair them up like this. X plus yi. That kind of thing is called a complex number. So each complex number has two real numbers associated to, or a pair of real numbers, or two-dimensional real numbers, basically. And we use this kind of term. We use the term real part of z is this x, and imaginary part of z is this y. We use this term. Real part and imaginary part. So this one is real, x part, and then this part is imaginary. So this is real, and then this one is imaginary part. Even though both x and y are real numbers, we use these kind of terms. That's what complex number is all about. Let's see, before going over to 1.2 algebra of complex numbers, maybe it's worthwhile considering some examples here. Two minus 3i, that's an example of complex number. I'm gonna run out of character. -2 plus 1/5 I. That's another example of a complex number. How about this? Or, yes, it's an example of complex number, but of course 0 times anything is 0, so any real number is also a complex number, and so on. These are examples of complex numbers. Now, what do you do with these? We can do some algebra. We can add, subtract, multiply, and divide. Let's consider the easiest, addition. So we have z1 and z2 like this. How do we add? Just regard I as any other character and take the like terms together. And we get the sum of two complex numbers is again a complex number. X plus yi form. See, this is a real part, and that's the imaginary part. How about the subtraction? Same deal. Take the like terms together. This is a real part, and that's the imaginary part. Simple. How about multiplication? All you have to do is FOIL it out, because we are using I as just any other character. But remember just one thing. Whenever I squared pops out, it is equivalent to -1. Let's see. First, a1 times a2, and there we go, a1, a2. Outside, a1 times b2i, we have a1, b2i. Inside, b1i times a2, so we have this. And finally, outside, finally is the last, FOIL, FOIL, b1i times b2i, b1, b2 times I squared. And I squared is equivalent to -1, so this whole thing becomes negative b1, b2. And then the middle part becomes the imaginary part. Conclusion? It's again an x plus yi form. So product of two complex numbers is again a complex number. Now division. Pay attention to this. This is something that requires some thinking and maybe the only thing that is worthy of exam problem. Okay, division. Here we go, a1 plus b1i over a2 plus b2i, alright. Then how do we simplify? We multiply something, some strategic quantity, to both numerator and denominator so that I don't change anything. And what strategic quantity is this? Start from the denominator, a2 plus b2i, and change the sign. That plus becomes minus. If we already start from negative, then changing the sign of the imaginary part, that will become plus. Now, if you multiply like this, well, just use FOIL method. The numerator, just FOIL it. Denominator, that too is just foiling. I'll leave the details to students. Or you can regard it as, let's see, x plus y times x minus y. So you can use x squared minus y squared. That too is a good way to look at it. In any case, please note that these two cancel each other out. And then this I squared part over here is -1, so we have sign change. This negative becomes positive. So what do we get? That's the denominator, a2 squared plus b2 squared. The result, the denominator became a real number. And then the numerator, we have real part and imaginary part. This real part and imaginary part, we can separate them. And the result is x plus yi form again. So the quotient of two complex numbers is again a complex number. So complex number system is closed under division as well. By the way, if I use the previous notation, we can write like this. Real part of z1 over z2 is equal to this expression. An imaginary part of this expression, z1 over z2, is equal to this. And let's increase the font again. Okay. So remember one thing, multiply the conjugate of the denominator. This thing is called conjugate. Multiply the conjugate of the denominator to both numerator and denominator. So how do you get conjugate? Just change the sign. It's easy. That's what division is. And what do you mean by conjugate? Yes, those jargons are here, but we're not going to use these very often in this course. So let's just move on to example. Here we go. Let's see. I think this is a good problem and the only worthy problem, I guess, because just foiling out, too simple. Another foiling out, too simple. This one requires some conjugation. And this one, basically the same type of problem. Same type of problem, except that we have to do the conjugation twice, so twice as complicated. But in terms of level of depth, the same. So let's stick to this one. So, all right. How to handle this? And let's increase the font a little bit so that you can see things better. Okay, all right. And then what do you multiply? The conjugate. 2 plus I divided by 2 plus I. You see, this part, which I'm highlighting in red, came from the denominator. and then we have the sign change, so it's called conjugate. And then let's do some computation. Just fold out the numerator. What do you get? First, 3 times 2, that's 6. And then outside, 3 times I. And then inside, 4 times 2. And then finally last, 4i times I, 4i squared. I wrote 4i squared, but most experienced students will just go ahead with minus 4 directly because I squared is -1. But I don't mind taking an extra step because I'm using a computer here. So let's do that. And then this one is going to be -1. Look at the denominator. First, 4, and then outside, inside, and then last. Again, experienced students will simply do, oh, this is -1, so change the entire thing into +1 right away. But I'm using computers, so I don't mind taking an extra step because I can always do this, copy and paste. This is -1, so we have sign change. And this is -1, so we have just sign change. I'll handle it like this. And then let's see, 3i plus 18i, what is this? That's 13i, isn't it? So 6 minus 4, 2 plus 13i. That's the numerator. Denominator, what do we get? 2i cancel out. 4 plus 1 is 5. And, well, that's okay for that's okay for me. And you're going to earn full credit if you stop here. But in case you have to answer my math lab, let's express it in x plus yi form. So 2 over 5 plus 13 over 5. Sorry about the typo. And that'll make this problem perfect. There goes an example of complex division. The other problem, just repeat it. I have 2 complex divisions here, 2 complex divisions here, and then I have to add them up. Just more tedious.